Hello students, today we will learn about the friction and laws of the friction. For that, we have already defined friction when we were studying about the Newton's third law of motion, in which we have seen every action there is equal and opposite reaction. And that time we have seen that the normal reaction. So once again I am just revising that point. When two bodies touch each other, each one exerts a force on the other. These forces are called contact forces. The component of contact force perpendicular to the surface in contact is called normal reaction, and the component of contact force parallel to the surface in contact is the force of friction. And clearly normal reaction and force of friction are perpendicular to each other. So when we define friction, we'll see according to Newton's first law of motion, a body moving uniformly along a straight line would continue to do so unless an external force is applied on it. But in practice, we find things otherwise. For example, a ball rolling over the floor stops after some time. Similarly, when we stop pedaling our bicycle, it comes to rest after traveling a certain distance. Again, when we switch off the engine of a car, it stops after traveling some distance. All these examples shows that there is there is uh, mm, there is some invisible force that opposes the motion of one body over the other, and these opposing forces are called friction. Again, when we apply a small force on a block, it does not move. The applied force must have been balanced by an opposing force of friction. Thus force of friction comes into play even when one body tries to move over the surface of other. Hence we define friction as an opposing force that comes into play when one body actually moves, slides or rolls or even tries to move over the surface of another body. Thus force of friction is the force that develops at the surfaces of contact of two bodies, and these opposes their relative motion. So after that we'll see how means the origin of the sliding friction. The origin of sliding friction. We'll see there are the means two theories. One is the old view and another is the modern view. So first of all we'll see the means according to old view, that roughness of surface is the cause of friction. According to the old view, roughness of surfaces is cause of friction. A surface which appears very smooth to the naked eye is found to have irregularities or roughness when seen through a powerful microscope, and this is true every surface. You will see that in the figure it is given here. The figure you will find here, you will find in this figure, this is the rough surface. This is the rough surface you will find here. Okay, and you will see that the in this, because of the roughness of the surface, the friction arises according to the old view. Okay, now you will see here in this you will find this is true of every surfaces, and when two bodies are in contact with each other, the irregularities in the surfaces of one body get interlocked. You will see the interlocking in the figure. The interlocking is there, so these are interlocked in the irregularities of other surfaces, and to move one body over the surface of the other, this interlocking have to be broken. Hence some force has to be applied, and this applied force is measure of friction between the two surfaces in contact. And means what are the limitations of old view, why we are not following this view? So for that we'll just give some points The old view of origin of sliding friction predict that, first of all, the larger the area of contact between the surfaces, greater should be the force of friction between them. However, experiment shows that force of friction between any two surfaces in contact is independent of the actual area of contact between them, because as according to the old view, it is said that due to the irregularities or due to the roughness of the surface, the friction force arises. So you can see that how much larger surface would be there, you will get that much large friction force. But due to the experiments, or from the experiment it is verified that means the larger force will be if the surface area which are in contact will be larger, it is not necessary the friction force is large. That we'll see in the experiment. Okay, so this is the first point that denied this old view that roughness of surface is cause of friction. And second point, you will see that in second point you will find here, when surfaces in contact are extra smooth, force of friction between them should almost vanish. However, it is found that force of friction increases when surface in contact are extra smooth. So extra smooth surface is there, that means again it is opposite to this old theory that says or that said roughness of surfaces is cause of friction. And we just now we find that if the surfaces, the two surfaces which are in contact are very smooth, extra smooth, then also the friction arises. Okay, then also the friction would be very large, and this type of friction is called actually the cold welding. It is not given here. This is called the cold welding. And when we learn about the molecular theory of this friction, or the modern view of friction, we'll learn about it more. Okay, so you will see now the second view, or we can say the modern view of friction. In modern view of friction, it is said that it arises on account of strong atomic or molecular forces of attraction between the two surfaces at point of actual contact. You will see in the figure, here it is given in the figure. You will find in this figure, you will find these two surfaces, this is one and this is second. These two surfaces are in contact and the area of contact is this much. Okay, and between these two surfaces you will find the atomic or the atoms means the area of apparent contact, it is looking here, and the interlocking or the corrugations are there. So area of actual contact you can see easily. Okay, you can see the area of actual contact here, it is visible to you, I think so. Okay, and you will find that in this the atoms or the molecular forces are working together in this means the two surfaces which are in contact, there are two type of atomic or molecular forces. So we'll learn about this, that on account of roughness of surfaces only the high point touch one another, therefore the actual microscopic area of contact is much less than the apparent macroscopic contact area. You will see the large area, it is appear that would be in contact, but actually you will find very small area are in contact, and these areas are roughly in the ratio 1 to the power 1 ratio 10 to the power 4. At the contact point, the molecules of the two surfaces are so close together that they exert very strong intermolecular force of adhesion on one another. As actual area of contact is very small, therefore the adhesive pressure, that is the force upon area at the point of contact, become too large. Okay, so actually I just want to explain you about the force of adhesion also. The meaning of force of adhesion is what here. Actually, you will see the two surfaces which are in contact, suppose consider a table and a duster. Okay, so a table and a duster are in contact, so the dusters are having some atoms or molecules you can see, and the atoms and molecules of that dusters are applying force on each other, and that is the intermolecular forces. These forces are called intermolecular forces of cohesion. Okay, that means the same molecule or the identical molecules or the molecules of a material are in contact, or they are applying the intermolecular forces. So that intermolecular forces are called force of cohesion. And but the molecule of duster and the molecule of table, if they are applying the force on each other, and that force, here also the molecular force will be there, and this is also called as intermolecular forces, but these forces are called the intermolecular forces of adhesion, okay, on one another. So here the adhesive pressure you will find at contact point may deform plastically and become cold welded. As I explained to you, if the surfaces are very large, very extra smooth you can say, so cold welding will take place. Okay, so here you will find so much so that many of the contact point may deform plastically and become cold welded together. When one body tries to move over the other, it involves rupturing of thousands of such tiny cold welds, and these give rise to opposing force of friction. So note that tiny cold welds reform continually as new chance contact are made. Okay, so according to the modern view of origin of friction explains satisfactorily the limitations of the old view. First, the friction force will be independent of the area of contact, which was given earlier in the old theory or old view, that friction force is the friction force rises because of the area of the contact. So it is proven now the friction force will be independent of area of contact. Okay, and this is because with increase in area of contact, force of adhesion also increases in the same ratio, and the adhesive pressure responsible for friction remain the same. So second point is that when the surfaces in contact are extra smooth, distance between the molecules of surfaces in contact increases the adhesive force between them, therefore the adhesive pressure increases, and so does the force of friction. So we may classify friction into two type now, the external friction and the internal friction. The external friction is what? Which arises when two bodies in contact with each other try to move, or there is an actual relative motion between the two. The external friction is also called contact friction. And internal friction, which arises on account of relative motion between every two layers of a liquid, internal friction is also referred to as viscosity of the liquid. And further, the external friction is of three types, that is the static friction, limiting friction, and the kinetic friction. We'll learn about it more in the next slide. Okay, so here it is clear to you now, the means according to the modern view, the force of friction is due to the force of adhesion or the cohesion. As the force of cohesion is very large comparison to adhesion force, in such cases you will find more friction will be there. Okay, so now we'll see the static friction, limiting friction, and kinetic friction. In this you will find now, first of all, static friction. So let us consider a block of weight mg laying on a horizontal surfaces as shown in a figure. When a body presses against a surface, the surface deform even if it appears to be rigid. The deformed surface pushes on the body with a normal force R that is perpendicular to the surface, and this called normal reaction, and it balances mg, that is the weight of the body. You can see here in the figure, you will find easily, you will find that, just look to the figure carefully, you will find force R is working perpendicular upward direction and mg is working perpendicular downward direction. Mg is the weight of the body, R is the normal reaction of the surface in which the body is kept, and the direction of motion is given here. So wherever the direction of motion is opposite to that, the friction force will arise here. Okay, so this is given in the figure that you can easily find out. Okay, now you will find the normal reaction, and this is balance because it is balance mg, so R equal to mg we can write in this way. You can say this as equation 1. Now you will see that suppose a small force P is applied on the block to the right as shown. We know from experience that a small applied force may not be able to move the body practically. Clearly, the body remains at rest because some other force F comes into play in the horizontal direction, opposes the applied force P, resulting in zero net force on the body, and this force F acting along the surface of the body in contact with table is known as friction force. So long as the block does not move, that force applied F is equal to P. That means the small force applied here, okay, that is we consider that force as P. A small force P is applied and that is equal to F. Okay, that means what you will find, you are trying to move any of the object, and if the object is not moving, that means you are applying the force, small force to the object, but because the force is not that much sufficient to move, to make move the object, so in such situation some forces which are opposing that motion is called the friction force, and that means if the you are applying a small force and the object is not moving, in that condition also a force of friction is there between the force of between the surfaces of contact. Okay, sorry, between the two surfaces of the two bodies, that means the surfaces of two bodies. Okay, so you will find here that friction in which is working when the objects are not in motion, so that friction is called the static friction. So we will define here the static friction in this way, that this means as we increase P, friction F also increases and remaining equal to P always. So the opposing force that comes into play when one body tends to move over the surface of another, this word, listen carefully, tends to move over the surface of another, that means it is actually not moving, but the actual motion has yet not started, is called static friction. That means the opposing force which are working between the two surfaces of the two bodies which are in contact are called static friction until unless the object are not moving or the object are in a static position. Static, that means stationary position. So that is a misconcept. The friction force is always appear or always rises when the object is in motion. It is not true. The friction force can arise between the surfaces of two bodies when the two objects are not moving over each other, not sliding over each other. Okay, and that friction force is called static friction. The word static means stationary, it is in rest. Okay, so we may also define static friction as the force of friction which exactly counterbalance the applied force during the stationary state of the body. And note that the static friction does not exist by itself. When there is no applied force, there is no static friction. It comes into play the moment there is an applied force. As the applied force P is increased, F also increases, remaining equal and opposite to the applied force up to a certain limit, and that is why the body does not move. Hence, the opposing force F is called static friction. And note that the static friction opposes impending motion. Impending motion, that means the motion which is pending, the motion which is not taking place actually, the motion, that means the motion not started actually. Okay, so the term impending motion means motion that would take place under the applied force if friction were absent. The impending motion does not actually take place. As we increase the applied force, a stage comes. As we increase the applied force here, we see that the stage come when the body is just at the verge of motion over the other, and the static friction at this stage is obviously maximum, and this maximum value of static friction is called limiting friction. Hence, limiting friction is the maximum opposing force that comes into play when one body is just at the verge of moving over the surface of other body. Verge of moving, that means it just started. The limiting friction is the friction force which is working between the surfaces of two bodies when the object is in verge of motion. That means it is just started the motion. At that, friction force will be maximum, because this is the friction force which set the object into the motion. So among all the friction force which we are just studying here, static friction, limiting friction, and the friction which we will study now, that is the kinetic friction, among these friction you will find the limiting friction will be maximum, because this is the friction which is responsible to make the object move. Okay, to make the object in motion. So limiting friction, once again we are defining here, the limiting friction is the maximum opposing force that comes into play when body is just at verge of moving over the surface of other body. And when we increase the applied force slightly beyond limiting friction, the actual motion starts. This does not mean that friction has disappeared. It only means that the applied force is now greater than the force of limiting friction. The force of friction at this stage is called kinetic friction or dynamic friction. So, kinetic friction or dynamic friction will define in this way. The kinetic friction or dynamic friction is the opposing force that comes into play when one body is actually moving over the surface of another body. Okay, so one body is moving actually when the you will find actually moving over the surface of another body. Okay, so you will find now it is found that the force of kinetic friction depend on normal reaction, on quality of finish of rubbing surfaces. It does not depend upon the area of contact, but the kinetic friction does depend, though to a small degree, on the velocities of relative motion of the bodies. If we plot a graph between the applied force and the force of friction, we get a curve. Here it is shown in the figure. You will see this type of curve we will find, and the part OA of the curve represent static friction. Look at the curve carefully. Fs, which goes on increasing with applied force. At A, the static friction is maximum, which represent the limiting friction, and Fl, which is equal to OL. Beyond A, the force of friction is seen to decrease slightly. The portion BC of the curve therefore represent the kinetic friction, which is written as Fk, that is equal to OK, and we have ignored here the slight dependence of kinetic friction on velocities of relative motion of the bodies, and also we find that kinetic friction is always slightly less than the limiting friction. So this is because once the motion start, actually inertia of rest has been overcome. We required more force to make the object move. That means just more force we required to overcome from the inertia of rest. Okay, and that's why the limiting friction is more here. Also, when motion has actually started, irregularities of one surface have little time to get logged again into the irregularities of the other surfaces. Okay, so this is all about